before we get into the last part of section 2.4, we need to remember something from college algebra that you may or may not remember or really ever been exposed to. And that's, if I had an equation like an e with an exponent, like e to the x squared equal to 0, or e to the 5x plus 7 equal to 0, or e to the square root of x minus 14 times the cube root of x equal to 0. Any equation where the left-hand side is e to some power and the right-hand side is 0, all of these have no solution. I'll show you what happens when we try to solve these, and why we say there's no solution. Each one of these problems, if I was asked to solve them, because they're kind of formatted the same way, I'd solve them the same way. And the way we'd solve a problem like this in college algebra is by taking a logarithm of both sides, because taking a logarithm allows you to drag an x that's stuck in an exponent and get it out of the exponent. And that's kind of the power of logarithms. They make it so we can get rid of exponents, or variables in exponents. And I wrote the ln because log base e is what ln is, and it's the most convenient base to solve this problem. So if I was solving this, I'd take the natural log of both sides, I'd drag the x squared, that's the exponent, on the left side, and make it a coefficient using the, I call it the power to product rule. I don't know what it's actually called, but that's as good a name as any. And then on the left side, the ln of e is 1. If I did ln and then second and divide key to get an e without an exponent, you'd see the ln of e is 1. So the left side's going to be x squared times 1 equals the natural log of 0, which gives me x squared equals the natural log of 0. The next thing I might do is take the square root of both sides to solve for x. But this side right here, this doesn't exist. Natural logs are only defined for numbers that are bigger than 0. And if eventually I'd have to use my calculator for this, and my calculator is going to tell me that natural logs, if I did natural log of 0, 0 is not in the domain of a natural log function. It gives you a domain error. And so what I'm getting when I'm going to solve this is x squared equals some error, and even if I square rooted that, I wouldn't get a value for x. Any of these equations, if I tried to solve them, eventually I'd do the same thing. So if I was doing the e to the 5x plus 7 equal to 0, there isn't really a way to solve it without introducing some sort of logarithm. So I take the logarithm of both sides, and boom, the second I do that, the right side becomes an error. And really there isn't a way to solve any of this kind of problem without a logarithm. And since logarithms are only defined when their argument is greater than 0, they're all going to have the same error. So in this section, while doing every problem at some point, I'm going to have to, I'll run across e to some power equal to 0, and that I'll just say there's no solution. I won't try to solve it. All right. So there's only 4 problems that we have to do to finish up this section 2.3, and each of the problems have the same instructions, and all our problems look the same again. So part A of each of the problems ask the question to find all values of x where the tangent line is horizontal. So immediately when it says find all values of x, I know my answer when I do part A is going to be x equal to some number, because I'm asked to find a value of x. The next thing I realize is these are instructions that I've seen before, and tangent lines are horizontal, mean the slope of the tangent line is 0, because horizontal lines have a slope of 0. And so that means I need to find out where the slope of a tangent line is 0, and you do that by finding the derivative and setting it equal to 0, because a derivative is a formula for the slope of a tangent line. When you set it equal to 0, that will give you the value of x, where the slope of the tangent line is 0, hence horizontal. So for each of the part A's, I'm going to first find the derivative, and when I do 62, I'm going to call that derivative y prime, and then I'm going to set y prime equal to 0 and solve for x. And that will finish up part A for each one of these problems. So part A, I'm going to just take the derivative, set it equal to 0, solve for x. In the middle of solving for x, somewhere I'm going to get an e to the x equal to 0, and I'm going to say that one doesn't have a solution. And the value R2 that I get for x, I'll write down. And I'll move on to 62b. If I look at the instructions for part B, it says find the equation of a tangent line. And to find an equation for a line, my answer is going to be of the form y equals mx plus b. It's going to be y equal to something, because an equation for a line has a y equal. And in order to get an equation of a tangent line, I have to have a point, a slope, and then once I have a point and a slope, I'm going to use the formula y minus y1 equals m times x minus x1. The nice thing about getting started on the part B, I'll have most of what I need. The answer to part A is going to be the x coordinate of the point that I'm going to need to do part B. I won't know the y coordinate, I'll have to do some algebra for it. And the slope for part B is going to be 0, because horizontal lines have 0 slopes. Alright, so that's enough to get started. So first part of 62, part A, find the values for x where the tangent line is horizontal. I take the derivative. And e functions are real easy to find the derivative of. You just take the e function, how it's given to you, and multiply by the derivative of the exponent. And that should give me y prime is 10x times e to the 5x squared, because the derivative of 5x squared is 10x. So first I'm finding y prime. Second, I'm setting y prime equal to 0. So I'm going to go 10x times e to the 5x squared equals 0. This is factored, or it's a product here, and so I'm going to set each of the factors equal to 0. I'm going to go 10x equal to 0 and e to the 5x squared equal to 0. For the 10x equal to 0, I just divide both sides by 10. On the left side, the 10's cancel. I'm left with an x. On the right side, any fraction with 0 in the numerator is equal to 0. So that's one of the answers to 62a. It's actually the only answer, because the second part is what I talked about at the beginning, and e to any power can never be equal to 0. So I'm done with part A. I'm going to move on to part B, and in part B, I have the x coordinate of the point that I needed. I have a slope. I need to get a y coordinate of the point. To get a y coordinate of a point, you take the x coordinate of that point and plug it into the original function. So I'm going to go y equals e to the 5 times 0 squared to get the y coordinate for that x equal to 0. And then the exponent comes out to 0, because this is e to the 5 times 0, because 0 squared is 0. That's e to the 0 power, and anything to the 0 power is 1. I wrote that in a big pink because I could shortcut my answer. So now I have everything I need to do part 62b. And if I want to be slick, when the slope of the tangent line is 0, the equation of the tangent line is just going to be y equal the y coordinate of the point that it's passing through. So each of the problems on the part B, once you get the y coordinate of the point, you know the equation for the line. For the first two, I'll show you how to do the algebra just in case you want to see it. The algebra way to get y equal to 1 is I'd go y minus, and then y1 is 1, equals m, which is 0, times x minus x1, which is 0. So I took x1, m, and y1, plugged them into the equation. The right-hand side, because it's 0 times anything, it's equal to 0, and then I add 1 to both sides. And I get y equal to 1, which is the answer to 62b. Again, the 62b's, once I get the y coordinate of the point that I want to find the equation of the tangent line, I can immediately write my answer, because when the slope of a tangent line is 0, the equation of the tangent line is always y equals the y coordinate of the point. All right, so you should be able to do 61. Pause the video and give it a go, and I'll move on and do 64. And for 64, part A, first step is to do a derivative. Because there's a product here, or multiplication, I need to use the product rule. And the product rule says take the derivative of the first factor, so I'm going to do the derivative of x squared times the second factor unchanged, which is e to the x, plus the derivative of the second factor, which is e to the x, times the first factor x squared unchanged. So y prime, the derivative of x squared is 2x, so I get 2x e to the x for the first piece. I should say e to the x here, not e squared. Plus, so it's 2x e to the x plus the derivative of an e function. You just take the derivative of the exponent and multiply it by the e function. So I have the e function. To the left of the e function, I take the derivative of the exponent. The derivative of x is just 1, and then times the x squared unchanged. For this problem, there's a common factor that I should factor out, and that common factor is an e to the x and an x. And when I take an x away from this side, that x is completely gone. But when I take an x away from this one, there's an x squared. When you factor an x out, you're going to be left with an x to the first power. So I'm going to write my common factor, a single x to the first power, and then an e to the x. And then I'm going to make a parentheses. The first thing I'm going to write is what's left over when I take the x and the e to the x away from the first factor, which is a 2. I'm going to bring this plus sign. And then when I take an e to the x and an x away from this piece, I'm still left with this 1. I don't really need to write that one, but it's okay to write it. And the x squared turns into an x to the first power. So now I have the derivative and it's factored. The second step of part A is to set the derivative equal to 0. So I'm going to go x times e to the x times 2 plus, and I'm not going to write the 1, 2 plus x equals to 0. There's 3 factors here, so I need to set each of the 3 factors equal to 0. So I'll go x equal to 0, e to the x equal to 0, and 2 plus x equal to 0. The x equal to 0 actually gives me an answer for 64a. One of the answers to 64a is going to be x equal to 0. That's an answer that I didn't have to do extra algebra to get. The middle problem is going to be a no solution. And the last one, I'd minus 2 from both sides and get x equal to minus 2. So 64a has 2 answers, x equals 0 and x equal negative 2. When I move on to do 64b, because the original problem, part A, has 2 answers, I need to get 2 lines. So my answer to part B is going to be y equals and y equals. I'm going to get 1 line for each x. Now for each line, I have to start off with a point and a slope. The first line I'm going to do is going to have an x coordinate of 0, and I'll do some algebra to get the y coordinate. The second line I'm going to get is going to have an x coordinate of negative 2, and I'll do some algebra to get the y coordinate. The slope of both of these are going to be 0, because the slope is what you set the derivative equal to. So for the first one, I need to get its y. I'm going to plug 0 in for the x's here. I'm going to go y equals 0 squared times e to the 0. That's going to give me y equals 0 times 1, which is 0. That's going to be the first equation. It's going to be y equal to 0. For the second equation, I'm going to plug negative 2 in for x and go y equals negative 2 squared times e to the negative 2. That's going to give me y equals 4e to the negative 2. And that's going to simplify to y equals 4 over e squared. And that's going to be what I need to finish up the second problem. So if I was doing the homework, that's as far as I'd go and I'd be done. If I wanted to do the actual algebra to do this, to get the answer properly, I'd go y minus y1 equals m times x minus x1 for both sets of information. The first y1 is 0, so I'm going to go y minus 0. The m is 0, and the x1 is 0. So I'd get y minus 0 equals 0 times x minus 0. Y minus 0 is just y. And then on the right side, anything times 0 is 0. So that's that one. And then the second set pair, I'd go y minus y1, which is y minus 4 over e squared, equals m, which is 0, times x minus a negative 2. Then I'd get y minus 4 over e squared equals 0, because anything on the right side is 0 times something which is 0. And then I'd add 4 over e squared to both sides. And I'd get y equals 4 over e squared, which is exactly what I predicted would be. So for 66 and 68, I'm not going to do the algebra part to get the equations for my lines because it's not necessary. When the slope of the tangent line is 0, the equation of the tangent line is just going to be y equals the y coordinate of the point. All right, so you should be able to do 63, and then I'll just have 66 and 68 to do. All right, here comes 66. Part A, I do the derivative. So I'm going to go y prime. It's a product because of multiplication, so I have to go the derivative of x plus 2 times the e to the x unchanged plus the derivative of e to the x times the x plus 2 unchanged. The derivative of x plus 2, the derivative of the 2 part is 0, the derivative of x is 1, so the derivative of that parentheses is just 1, and I don't need the parentheses anymore once I took its derivative, and the e to the x just falls down. The derivative of e to the x is just e to the x, because you take the derivative of its exponent, which is 1, times the e function unchanged. So that's the derivative. Now I'm going to pull out my common factor, and it's a smaller common factor. I just have a common factor of e to the x here. And when I factor out that e to the x, I get y prime equals e to the x times 1 plus, and I'm not even going to write that 1, it's not necessary, times x plus 2. I need to simplify the inside of this parentheses. So I'm going to get y prime equals e to the x times 1 plus x plus 2. I can just drop that parentheses without doing any changing. I get y prime equals e to the x times x plus 3. Almost done with 66a. Now I'm going to take the derivative and set it equal to 0. Since it's factored, I'll just split the factors up, set each one separately equal to 0. When I set e to the x equal to 0, there's no solution. And when I set x plus 3 equal to 0, I get x equal to negative 3. So my answer for 66a is x equal to negative 3. And now when I go to do 66b, so this was all 66a, when I go to do 66b, I have the x coordinate of my point, which is negative 3. I know my slope is m equal to 0. I need to get the y coordinate of my point, and that's going to give me my answer. My equation for my line is just going to be y equals whatever that number is. So to get that number, I'm going to plug negative 3 in for these x's. So I'm going to go y equals negative 3 plus 2 times e to the negative 3 power. That's going to give me y equals negative 1, e to the negative 3 power. That's going to give me y equals negative 1 over e cubed. That's the y coordinate of the point, and that's going to be the answer. And I'm not going to do the y minus y1 equals m times x minus x1 part for 66b, but I could have, and that's what it's going to give me, y equals negative 1 over e cubed. Alright, so you should be able to give 65 a go, and we just have 67 and 68 to do. Hopefully you don't need to watch me do 68 to finish up 67. So 67 and 68 there. To do 68 part A, I need to do my derivative. So it's a multiplication, so I need the product rule. Y prime is going to be the derivative of x times the e to the 3x function plus the derivative of the e to the 3x function times the x. The derivative of x is just 1, so this is going to be 1 times e to the 3x. The derivative of e to the 3x, you just take the derivative of its exponent, which is 3, multiply it by that e function, so it's 3e to the 3x, and I leave the time x there. I pull out my common factor of e to the 3x. I'm going to get y prime equals e to the 3x times 1 from there, and plus 3x from there. To finish up the part A, I take my derivative, e to the 3x times 1 plus 3x, and set it equal to 0. Since it's factored, I split the factors up. I go e to the 3x equal to 0, 1 plus 3x equal to 0. E to the 3x equal to 0 has no solution. For the 1 plus 3x, I minus 1 from both sides and get 3x equals minus 1, and then I divide both sides by 3 and get x equal to negative 1/3. That's going to be my answer to part A. Now I'll move on to do 68b. For 68b, the x coordinate of my point is negative 1/3. The slope is what I set the derivative equal to, which is 0. I need the y coordinate of my point, and my answer is going to be y equals whatever that comes out to be. So to finish this up, I need to get my y coordinate. So I'm going to go y equals negative 1/3 times e to the 3 times negative 1/3. That's just putting negative 1/3 in for both of the x's. That's going to give me y equals negative 1/3 times e to the negative 1. 3 and 1/3 are reciprocals, so they would multiply to 1. But since I have a positive times a negative, they multiply to negative 1. I'm going to move the e down to the denominator. I'll get negative 1 over 3e to the first. So the y coordinate of the point is negative 1 over 3e. I don't need to write the 1. And that's going to go in my answer. So my answer to part 68b, without doing the y minus y1 part, equals negative 1 over 3e. Again, I could have done this. I could have went y minus negative 1 over 3e equals 0 times x minus negative 1/3. This would give me y plus 1 over 3e equal to 0. And then I'd go minus 1 over 3e minus 1 over 3e, and I'd get that just fine. So that's the end of this section. So hopefully you can do 67, and then we have a word problem section to go.